Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions based upon variation in acceleration due to gravity, like due to depth, due to height, due to rotation of the planet and all that. Okay, so let's start the video. The first question is, an object of mass 100 kg falls from A to B, that means from A to B as shown in figure. The change in its weight corrected to the nearest interior is how much here, and where RE is the radius of the earth. Okay, so here you can see here, when the object is at a height A from the surface of the earth, let's take this one, I have taken here the height HA. Okay, after that when it will be at a height B, that means here at this point. So in this situation what will be, let's take height will be B here, HB. So here I can write here, see this 2RE minus RE by 2. So 2RE minus RE by 2, this will come here 3RE by 2. Okay, now after that, next one, if we will talk about here the formula. So what is the formula? Gravity due to height. The formula is given by, you should know some basic formula, GH is equal to G, and here I can write here R by R plus H whole square. Is it? After that, what I am doing here, if both the sides I multiply with the mass of the body. Okay, so I can write here this WH is equal to, I can write here W on the surface is R by R plus H whole square. Okay, this is the main formula. Now we have to calculate the difference of the weight, and you know very well when the object will be at point B, the height will be less, here weight will be more. So WB will be greater than WA, now because here height is less and at point A height is more. So here if I write here the weight at point B minus weight at point A, what is the formula? If I will use the formula here, weight means mg, so I can write here, see mg, and here it will come here. Now at point B I can write here, see R by R plus HB whole square minus next one R by R plus HA whole square here. Is it? Now next one we are just going to write here the values. Mass how much here? 100 kg. Gravity value is 10, so 100 into 10 means 1000 here. Okay, and here we are just going to write here the value. So this will become here R by R plus HB value how much here? You can see 3RE by 2, or I will just write here the R. Okay, just R. 3R by 2 square minus here R by R plus height A how much here? 2R. Okay, so 2R square here. Now, so here it will become here, kindly see, this will become here 1000, and here you can see R plus 3R by 2 means it will become here the 5R by 2. Okay, so R by 5R by 2 means R cancel. So here when you will simplify this, it will come here 4 by 25 here. Okay, 4 by 25, just simplify this. Minus, here you can see here R by 3R whole square. So R cancel, this will become here 1 by 9 here. Okay, and after that this has become very simple, just take the LCM and all that. Okay, very easily you will get here the approximate value 49 Newton. Exact value will come 48.88 at all, no? But here we can write very easily 49 Newton. Okay, so see the question here. Is it great? Now let's see, we'll move to the next question. The question is, the percentage decrease in the weight of a rocket when taken to a height of 32 km above the surface of the earth will be how much here? I hope so you know very well, because you have seen previous video. Whenever we are going above the surface of the earth, gravity will decrease and weight will also decrease. Even when we are going down also, so with respect to surface, gravity will decrease, weight will decrease, and at the center how much gravity? 0, weight also 0. So when you can see here, this is the 32 km. So remember that here up to 5% of the radius. What I am telling that here, up to 5% of the radius of the earth, or we can tell here up to 320 km here, because radius of the earth is 6400 km. Okay, so in this situation we can take that the rocket is very near to the surface of the earth. I can use the formula G equal to Gm by R square. Okay, after that I will write here the error equation for this. Now, error equation. So what is the error equation? I can write here, see delta G by G and here you can see here this G is the inversely proportional to R square. So from here delta G by G equal to 2 times delta R by R here. Okay, and here they are talking in terms of the weight of the rocket. Okay, so here just multiply with M, here also just multiply with M. So I can write here the change in weight of the rocket by original weight will be what here 2, and what is delta R? That means change in the radius. Let's take at the surface radius is R1, above the surface somewhat radius is R2, so R2 minus R1 will be what? That will be the height of the rocket. So we can write here see 2h by R. Delta R is the whatever is the height is there. Okay, so we can write here 2, height what is given here, see here 32 kilometer, so 32. Radius of the earth how much here, 6400 kilometers, so only kilometer should cancel out here. After that what will happen that here when you will solve here, it will come here 1 by 100, but here they are asking in a percentage. Okay, so hence we can write here hence percentage decrease in weight. Okay, percentage decrease in weight will be given here what, delta W by W into 100 here. Okay, so 1 by 100 into 100, this will become what here, kindly see here, it will become here 1%. So which option is correct here? The correct option is the option A is the answer. Now let's see the next question. So the question is, if R is the radius of the earth and acceleration due to gravity on the surface is pi square meter per second square, then the length of the second pendulum at a height h equal to 2r from the surface of the earth will be how much here? Okay, so students, here you can see the term is coming here second pendulum. Okay, so remember that second pendulum is a type of pendulum whose time period is always how much here, 2 seconds, whether the second pendulum is on the surface of the earth, moon, or at any height from the planet. Okay, so remember that here. So what I am going to take here, let's take here on the surface of the earth, the time period what is given here, anyhow 2 seconds, and the length used to be how much here, 1 meter, remember that here. Okay, and let's take when we are going to the height h, so that time again time period anyhow will be how much here, 2 seconds only, it will not change, and this length we have to calculate here, is it? So remember that here, see, as time period on the surface is equal to time period at height h. So what is the time period formula? You know very well, 2 pi root L1 by G1 is equal to 2 pi root L2 by G2, is it? Now what will happen that here, kindly see here, this 2 pi and this 2 pi cancel. So we can write here, see, this L1 by G1 is square root is equal to L2 by G2 square root. Let's take both the sides here square here. So when I will take both the sides square, what will happen that here, kindly see here, this will become here L1 by G1 is equal to what, L2 by G2. So hence what is the L2? L2 is given by, see here, G2 by G1 is equal to what, L1 here. Okay, now what is the G2 by G1? For that we should know the gravity formula. See here please, gravity at height h and the gravity on the surface, what is the formula? R by R plus h whole square here. Okay, so I will write here, see, R by R plus h whole square into L1. Now what is the value of the h? Let's see here, the value of h is 2r. So when you will put here, see, R by R plus 2r whole square, so this will become here R by 3r whole square, R by 3r whole square into L1. And what is the value of the L1? 1, is it? So after that just simplify this R and R anyhow, it will get what, cancelled. So you can tell here the value will be how much here, 1 by 9 meter. How much here, can you see, 1 by 9 meter. So I have told you second pendulum always time period fixed 2 seconds. Length may vary, but the time period will be always fixed 2 seconds. Now let's see, the next question is, a body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? So towards the center of the earth, now let's take here, this is the center of the earth, and we have went halfway down is there. Now let's take how much, this much we went. So d equal to how much here, r by 2, and anyhow the radius of the earth is how much here, r. Okay, so here you remember the formula here, the gravity at depth d is given by g times 1 minus d by r. And now if I multiply both the sides with the mass of the object, for example, then I can write here weight at depth d is equal to weight on the surface, and here how much here? 1 minus d by r, is it? And what is the weight on the surface? You can see 200 Newton is given here. So 200, 1 minus depth, what is given here? You can see halfway down. D value how much here? R by 2. So r by 2 by r. So we can write here 200 1 minus 1 by 2, is it? So 200 into 1 by 2, what will come here? The answer will come here 100 Newton. As gravity will be decreased by half, so weight will also decrease by half here, because weight is the directly proportional to the gravity. Okay, remember that here. Next one, let's see. The question is, at what distance above and below the surface of the earth a body will have same weight? Take a radius of the earth, how much here? R. Okay, so what we are going to take here, let's take here, this is the earth and the radius is r, this is the center. So from here what is happening, let's take, we are going some height up and we are going some down also. So let's take height is h and depth is d. So here what is happening, that here at both the points here, let's take here, this is point A, and inside let's take point B. At both the points what should be there? The gravity value should be same. So from here you can tell very well here the value of depth is equal to height here, is it? After that, let's see, we know here the gravity, see, the GD should be equal to what here, students? GH. So what is the GD? GD is given by, see here, G1 minus D by R. And here what is GH? G R by R plus H whole square here. See, R by R plus H whole square here, is it? So what will happen that here, see, both the sides G and G will cancel. Okay, so from here I can write here, see, this is 1 minus D by R is equal to, this will become 1 by, and R will go down, so 1 plus H by R whole square. Okay, so now as we know very well, D equal to H only, but now what I am going to do, both the sides I will divide with the R. Now anyhow both will be same only, and this thing only I have taken here X. Okay, so what this will become here, you can write here, this will become here 1 minus X is equal to 1 by, here you can see H by R, I will put here X. So this will become here 1 plus X whole square here. Okay, so 1 plus X whole square will come this side. So 1 minus X, 1 plus X square formula. 1 plus X whole square formula, 1 plus X square plus 2X is equal to how much here? 1, is it? So first we are going to get the value of the X, then we can get H or D. So just multiply 1 inside, so 1 plus X square plus X. Then after that minus X, so minus X minus X cube, and what this will become here, minus 2X square is equal to 1, is it? Now what will happen that here, see, this and this 1 is cancelled here. Okay, and after that we can write here, see, this is X square minus 2X square, so this will become here minus X square, and here you can see here minus X cube, and here plus 2X minus X, what is coming here, plus X is equal to how much here? 0. Okay, so now after that if we will write here in a, still we can take here, let's take here, I have taken here, for example, minus X common I have taken. So what this will come here, see, X plus X square minus 1 is equal to 0. So X cannot be 0 here, is it? That means what this will happen that here, see, this will become here X square plus X minus 1 should be 0 here. What is coming here, see, X square plus X minus 1 should be 0 here. Now we'll write here the Siddharacharya method. So when I will compare this one with the AX square plus BX plus C equal to 0. So you can see very well, no? What is the value of the A? The value of the A will be 1. The value of B will be how much here? The value of B will be, you can see here 1, is it? And the value of C will be what here? The value of C will be how much? Minus 1, is it? So from here what is the X value? You know the formula, see, minus B plus minus square root of B square minus 4AC by 2A. So just simplify this. Minus B means minus 1 plus minus, and B square minus 4AC, when you will put the value, it will come here root 5 by 2 into 1. So from here, you know the value of X will be always positive only, is it? So I can write here, see, minus 1 plus root 5 by 2. This is the value of the X. What is this? This is the value of the X. So at the end, I can write here, see, the X means I can write here, see, this H by R is equal to, what is coming here? We can write here, see, root 5 minus 1 by 2. So from here, what is the value of the H? R will be multiplied. So root 5 minus 1 by 2 into r. That means which option is correct here? Kindly let's say here the correct option is the option D is the answer. Is it? Kindly see here. Is it? Okay, great. Now let's move to the next question. The question is see, the acceleration due to gravity at a height 1 kilometer above the earth is same as at a depth d below the surface of the earth. Then what is the value of the d? So remember that here in the question they are telling that here the value is same. So here please, gh is equal to gd, and you know very well here they have given very small height is they have given 1 kilometer. So for very small height, that means we can tell here when h is less than r, we can use the formula g 1 minus 2h by r is equal to g, and here how much here 1 minus d by r. You can see very well the formula is looking very similar. That means this 2h is equal to d. Is it? That means remember that here we can tell here, see, d is equal to 2h here. H value what is given here? 1 kilometer. So hence the d value will be what here? 2 into 1 kilometer. That means what is the answer? 2 kilometer. Is it? So where is the answer? C. Option C is the answer. Is it? Great. Now you can see the next question is here. The next question, let's see. Given below are two statements. Let's see one by one. Statement 1 is what? See, acceleration due to Earth's gravity decreases as you go up or down from the Earth's surface. Yes, it will be there, because see here, if I draw here the graph also, see, this is the R center to the observation point here, and this is the gravity value. And let's take here, this is the surface representation, small or equal to capital R here. So what will happen that here? Remember that at the center of the Earth, the gravity value will be 0, from center to surface increase, and after surface it will decrease. But if in case I take here, this is my reference with respect to the surface, this is the surface. So with respect to surface, you go this side also, gravity value decreasing, you go this side also, gravity value is decreasing. So whether you go up or you be inside, gravity value will decrease. So correct option is the statement 1 is correct. Now if we talk about here the statement 2, let's see here. Acceleration due to Earth's gravity is same at height h and depth d from Earth's surface if h equal to d. Anyhow, no, because before also you have seen that here, you can see here what was there? D equal to 2h. Even in before question also we have seen that. Okay, so what will happen that here the gravity is not the same at h equal to d, because here you can see straight line graph, here you can see the graph is decreasing, g inversely proportional to r square. Okay, that means this statement is wrong. So statement 1 is right, statement 1 is wrong. So which option is correct here? See here, statement 1 is correct, statement 2 is incorrect. The correct option is here, option C is the answer here. Is it? Great. And this also you can see very well. Okay, so now after that, students, we'll go for the next question. The question is here, let's see, the question is C. Suppose that angular velocity of rotation of Earth increased, then as a consequence. What they're telling that here? Angular velocity of Earth is increased here. Okay, so see, option A, there will be no change in weight anywhere on the Earth. Option B, weight of the object everywhere on the Earth will decrease, weight of the object everywhere on the Earth will increase, except at poles, weight of the object on the Earth will decrease. So here remember that here we should know the gravity effect due to the rotation. So due to the rotation, what happened that here? G lambda, that means at latitude lambda angle, G lambda is given here, G minus R omega square cos square lambda. Okay, now if we talk about here on the equator, this lambda value will be how much here? 0. Okay, so on the equator this will be how much here? G minus R omega square. At the poles, this lambda value will be 90 degree and cos 90 is 0. So at the pole GP how much here? G. So from here you can see very well, except at poles, weight of the object on the Earth will decrease. Why? Because you can see here minus is there na. So from here I can tell here the gravity at equator is inversely proportional to omega, because minus is there. So correct option is what here? Option D is the answer. At pole, rotational effect does not matter because lambda is always 90 degree here. Is it? Great. Let's move to the next one. See, given below are two statements. See, statement 1, rotation of the Earth shows effect on the value of acceleration due to gravity. Yes, because of the rotation, gravity place to place different. Okay, now statement 1 is correct. Correct only. Statement 2, the effect of rotation of the Earth on the value of G at the equator is minimum and that at the pole is maximum. No, because on the pole there is the no effect of the rotation of the earth. The rotation of the earth effect is there only where? Only on the equator. That means statement 2 is what? Wrong. Statement 2 is wrong. So here you can see statement 1 is the right, statement 1 is wrong. Is it? So statement 1 is right, statement 1 is wrong. You can see the correct option is the option D is the answer. True and false. Right, wrong. Is it? Great. Now let's see. The next question is what here? See. The acceleration due to gravity on the Earth's surface at the poles is g, and the angular velocity of the Earth about the axis passing through the pole is omega. An object is weighing at the equator and at a height h above the poles by using a spring balance. If the weights are found to be same, then h value how much here? So see please here, at a height of h, where at the pole they are seeing the weight here. Okay, so we'll just see here. The situation is what here? According to the question, what is happening that here? On the pole we are going at height h, and this weight is equal to the equator weight. Now, so remember that here, even on the pole also, on the surface gravity how much here? G, independent of the rotation of the earth. And when we are going height h, so this will become here what? G by r plus h whole square here. Is it? This will become here. After that, in this situation, what will have happened that here? One more situation, one more thing. Why we cannot use this formula? Because the problem is what? In the formula, see here please. They are telling here h less than r. That means no need to use the exact formula. We will use the approximate formula. Okay, so see. 1 minus 2h by r is equal to g minus r omega square here. Okay, and see here, this is on the surface of the pole. This g, is it? No, we can't cancel here. So see, let's multiply here. See, g minus, you can write here, see, 2gh by r is equal to g minus r omega square. Now this g and this g is cancelled here. Is it? So next one we can write here, see, this 2gh by r is equal to r omega square. Is it? So hence, if I write here the value of the h, this will become here, see, r square omega square by 2g. Why we have used the formula g times 1 minus 2h by r? Because h they have given in the question less than r. So which option is correct here? R square omega square by 2g. The correct option is here option A. Okay, great. Now let's see. The question is here. Let's see the question. A box weighs 196 Newton on spring balance at the North Pole here. Its weight recorded on the same balance if it is lifted to the equator is close to, and g value is given 10 meter per second square, and all these things are given. Okay, so let's take here please. Again they are telling that here weight on the 196 Newton is where? At the North Pole. So on the pole anyhow you can see here mass into gravity, the gravity value will not change. Is it? So this is how much is given here? 196 Newton here. Now they are asking here same weight, the same object will be how much here? On the equator here. Okay, so see here please. On the equator, if I write here this GE value, so what is the formula? See, G minus R omega square. Okay, so after that I will just multiply both the sides with mass m. Here also I will multiply with the m here. Okay, so you can write here, see, weight on the equator will be how much? Mass how much here? You know very well here, mass. Mass means 196 by g value on the where? Pole. How much is given here? 10. So I can write here how much mass? 90.6 kg. 19.6 kg. Okay, so I will write here, see, this is 19.6. The value of g is 10 minus r, radius of the earth, what is given here? See, 6400 kilometers. So 6.4 into 10 to the power 6 meter. Omega value, omega means 2 pi by capital T. What is the rotation of the earth? Time period 24 hours. So 24 into 3600 square. This we should know this all. Okay. So after that what will happen that here? The weight on the equator multiply 19.6 into 10. Again this will become here 196 minus. and 19.6 will go that side here. So when you will multiply this 19.6 here, this will come here nearly 0.034 here. Okay, some calculations are there. So when you will simplify this, the value will come here approximately 195.33 or 32 Newton. So which option is correct here? Remember that here, this one here. Anyhow, what will happen that the weight will decrease, gravity will decrease. Actually 196, it will decrease here, 195.32. Okay, now after that, the next question is what here? The question is, see, if the earth has no rotational motion, the weight of person on the equator is W. Rotational motion is not there. Now, determine the speed with which the earth would have to rotate about its axis so that the person at the equator will weight how much? 3W by 4. Radius of the earth is this one here. So you know very well here, when no rotation. What I am telling that here, when the earth is not rotating, the gravity value on the equator, what will happen that here? Anyhow, GE will be how much here? G here, no? Because omega is 0, earth rotation is not there. No rotation means omega how much here? 0. Okay. So in this situation, you also know one more thing as weight is directly proportional to G. Is it? So what is weight is there? W, and corresponding to that gravity how much here? G. So what will happen that here? GE equal to G. Now after that, what will happen that here? With rotation. When it is rotating, so with the rotation, what will happen that here? Let's take here. Now new value of the GE dash. GE dash will be how much here? How much here? The weight is becoming 3W by 4. Mass will not change. So if the weight is becoming 3W by 4, gravity will also become how much here? 3G by 4 here. Okay. So when the earth is not rotating, gravity on the equator is G, weight is W. And when the earth is rotating, let's take here with angular velocity omega, weight is becoming how much? 3W by 4, because gravity how much here? 3G by 4. After that, what will happen that here? We have to just write here the formula. Okay. So what is the formula? You know very well here. Gravity on the equator is given here, G minus R omega square. Is it? And anyhow, what is this here? When the earth is not rotating here, and when the earth is rotating. This is when earth is rotating, and this is when earth is not rotating, anyhow G only. So GE dash is coming what here? Kindly see please. 3G by 4 is equal to, when the not rotating, that time only gravity G, minus what will happen that here? See, R omega square. Okay, so from here we will just simplify this here. See, R omega square is a G minus 3G by 4. So from here we can tell R omega square, what this will become here? 4G minus 3G by 4. So this will become here G by 4. So hence you can tell here omega square will become here G by 4R here. Is it? So hence omega is coming what here? The earth should rotate with the root G by 4R. Okay, but here we have to get the value. So hence omega will come here root G value. How much is given here? No, G value, let's see. G value, anything they have given? Yes, they have given 10. Okay, so G value is the 10 now. And 4 as it is, and R value how much here? 6400 kilometers. 6400 kilometers. So I can write here 6.4 into 10 to the power 6. Or I can write here 64 into 10 to the power 5. So here this will become here, see, 1 by 4 into 64 into 10 to the power 4. Is it? Now let's see, when you will simplify this, this will come here 1 by 2 into 8 into 10 to the power how much here? 2. Is it? But let's see how the answer is coming. Answer is coming in a 10 to the power minus 3 here. Is it? So what we can do here? Let's take here. This is becoming 1 by 16 into 10 to the power minus 2, or we can write here, see, 10 by 16 into 10 to the power minus 2. Okay. And 10 by 16, when you will simplify this, approximately it will come 0.6 something. Okay. So because 10 by 6, or we can tell 5 by 8, approximately 0.6 into 10 to the power minus 2. Unit what will come here? Radian per second. Kindly see very well. Is it? How much they are asking question based upon equator and pole. So which option is correct here? The correct option is here. Option C is the answer. Is it? So students, I hope so. This video based upon the questions of variation in acceleration due to gravity is very, very clear to you. Keep studying, keep growing.